The Earth is heated by infrared radiation from the Sun. Remember that objects absorb infrared waves to gain heat and emit infrared waves to release heat. The Sun and the Earth is an example of this process. Nuclear fusion reactions in the Sun cause it to release energy as various electromagnetic waves, including infrared radiation. This heats up the Earth, increasing its temperature to a point where its ecosystems can thrive. Importantly, infrared waves are the only way of transporting heat from the Sun through a vacuum to reach the Earth. Without these waves, the Earth would be too cold to support life. But what then stops the Earth from getting too hot? Well, the Earth will emit its own heat as infrared radiation in all directions. We often model the Earth and other planets as black bodies, meaning they're very good at both absorbing and emitting radiation. So the Earth will be constantly emitting infrared radiation out in all directions. In fact, all points on the Earth's surface will be emitting this radiation at roughly the same intensity. So the Earth releases some of the energy it gains as it heats up. This helps keep the Earth from getting too hot to support life. By only keeping some of the heat from the Sun, its temperature will not be constantly rising. But if all points on the Earth are releasing roughly the same amounts of heat, why are some parts of the Earth hotter than others? Well, the Earth is hottest at the equator as the infrared radiation from the Sun strikes the Earth directly here. So the Sun emits infrared waves in all directions, with only a small amount of these hitting the Earth. We can assume this set of waves will be travelling roughly parallel to each other. This pattern affects how much energy each point on the Earth receives. For example, let's consider this point here, which is on the equator of the Earth. We see that these two arrows are both close to this point, and they're hitting the Earth at almost a right angle to its surface. This means that this point receives lots of energy from these waves, making the equator hot. Now let's consider this point here, at the North Pole. Now the only ray in the pattern that comes close to this point is this top ray. This ray looks like it won't hit the Earth directly, but rather brush past it. This means that the North Pole receives very little energy from the infrared wave, making it very cold. But is there anything else that affects the temperature of a point on the Earth? Places are much cooler at night as the dark side of the Earth releases radiation but does not gain any from the Sun. So remember that these aren't just infrared waves being sent by the Sun, but visible light as well. So it will be nighttime on the other side of the Earth, as it's not being illuminated by the Sun. This will also affect the temperature of the Earth's surface. During the day, the surface is receiving energy from the Sun and also releasing energy as its own waves. This means that this side of the Earth is being both heated and cooled. Then for the side of the Earth where it's night, the surface won't be receiving any heat from the Sun. However, it will still emit waves and release heat. So this side of the Earth only cools. Therefore, it will be colder at night than during the day. For your exam, you should be able to explain why the temperature of the Earth's surface will vary. Drawing this diagram can really help with your explanation.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!